Today's session is about network policies, Kubernetes or Calico network policies on Openshift. My name is Ivan Sharamok. I'm a solutions architect at Tigera. And here's a brief agenda for today's meeting. I'll go through some intros, a few words about Calico and Tigera. We'll take a look briefly in how Openshift configures the networking and the enforcement for the endpoints. We'll take a look at a few examples for network policies, quick comparison between cloud native approach to security and traditional security. We'll go through a few Calico enterprise features, and if we have time left, I'll jump and show a few demos. Along the session, feel free to post your questions in the Q&A section or in the chat. I'll check those at the end of this session, and we'll answer the questions. So the first things first, what is Project Calico? If you have worked with Kubernetes, you have probably either heard of Calico or using it today. Project Calico is a community-built, developed and maintained project that is open sourced, and it provides networking and network security solution for containers, virtual machines, and host-based workloads. The Calico design was built to allow layer 3 network setup without encapsulation, which makes the setup very clean, very easy to troubleshoot for anyone, for any network engineer. Any traditional tools, standard tools would be enough to look at the traffic and see what's happening in there. Calico leverages native Linux data plane, which allows it to get very good performance as close as possible to what you would get with using kernel features. It uses border gateway protocol, BGP, to configure the routing between the nodes and pods, which allows us to scale quite fast to very massive numbers in Kubernetes. We can hit the number of nodes, and Kubernetes would start dying before Calico starts dying. The wide adoption of Calico for its network policy enforcement has been recognized by the community and was adopted by all large public cloud providers like AWS, Google, Azure, and IBM, also embedded into package solutions like Docker, Enterprise, Rancher, and integrated with Red Hat's Openshift. We worked with our customers, large organizations, and some of the largest SaaS companies since early days of Kubernetes, which allowed us to make sure that the product, the Calico, is hardened for production use and can deliver on the expectations. If you're looking to get engaged or looking to get some help, here are a few channels where you can reach us. You can follow us on Twitter. Slack channel has today close to 5,000 members in there. It's very active. If you have any questions that we would not cover today, feel free to join and post your questions in there. It's a very vibrant and very active channel. The project itself hosted on GitHub under Project Calico account. And as of today, we know of over 150,000 clusters that in total combine of over 1 million nodes that run Project Calico, and we have over 150 active contributors to the project. To another slide, just to show you the span of where Calico is used and have been adopted in various combinations. From the left-hand side, where you see the public cloud providers, and their managed Kubernetes offerings. In most of them, Calico is used for network policy enforcement, and some of them have added the support for even using Calico for networking, like Calico CNI. In case of EKS, recently added that support. You can always use it with upstream Kubernetes or packaged solutions like Docker Enterprise, developed by Mirantis, Openshift by Red Hat, Rancher, Canonical, VMware Tanzu, D2IQ, and moving all the way to the right where you can install it on-prem on your on-prem Kubernetes cluster, or even on VMs and bare metals that are not necessarily part of your Kubernetes cluster. You can install a Calico agent in there and connect it to the Kubernetes control plane or Calico control plane in Kubernetes and get the policy updates on those machines as well. Calico today is the only solution that offers networking and network policy solution for Linux and Windows. In Linux, we support IP tables and eBPF data planes. On Windows, we are working with Windows HNS. The Linux eBPF was G8 2 releases back in Calico open source and recently added to Calico Enterprise. So let's take a look into the how OpenShift sets up the cluster and for network connectivity and policy enforcement. OpenShift leverages the existing either cloud or physical network and relies on that setup for node-to-node connectivity. Then which it configures to set up its Kubernetes configuration, which then leverages the Linux network and on each node the kernel features to set up the routing between the pods. Pods run in their own namespaces on each of the nodes and leverage the Linux kernel to configure the routes and establish the communication between the pods. Once you have the CNI set up that supports policy enforcement, you get ability to enforce. It provides the firewalling ability for your pods. So now you can control, you can create rules to control egress, ingress to and from your pods. With Calico, you also get ability to control not only the interface, the pod interfaces, but also the host interfaces. So you can create network policies where you can protect services that are running on the host itself and not necessarily as Kubernetes pods. It's worth mentioning that by default, OpenShift installs with OpenShift SDN, which provides you just this level of policy enforcement where you can protect your pod interfaces, and it's only for ingress, and I'll talk about that in a moment. Once you get a CNI that supports more advanced features like Calico, now you can expand that and go further and apply policies even to the host level. Here's a brief comparison between the what OpenShift offers out of the box, what Calico open source offers, and what Calico Enterprise offers. Calico Enterprise is a product built on top of Calico open source with some advanced features and capabilities. So for the basic networking, OpenShift and all Calico versions provide you that CNI plugin that you can use. Calico can also work with many other CNIs, like in managed solutions in Kubernetes managed solutions, like in EKS, AKS. The CNI is provided by the cloud provider, but Calico can be used in conjunction to provide the policy enforcement features. So if you're when you're using Calico, you'll get some advanced features like peering with your existing infrastructure without overlay. some Calico provides its own network policies, which are a superset of Kubernetes standard Kubernetes network policies. The integration with Istio Envoy allows Calico policies to get application layer rules in them. And in Calico Enterprise, you get additional features like DNS controls, the DNS rules for network policies, multi-cloud federation, and multi-cluster support. You can have a single pane of glass if you have multiple clusters across different environments, across maybe different cloud providers, and you want to get a single view of what's happening in your clusters in terms of networking traffic, in terms of policies, in terms of any anomaly detection. Calico Enterprise provides you with that feature. All the controls and resources in Calico Enterprise can be configured to use Kubernetes RBAC, so that you can tighten the access to who can do what with the Calico resources, which will give you also audit trail and compliance controls. There are additional features in alerting and monitoring and any anomaly detection that can happen in your Kubernetes cluster, and Calico Enterprise has those features to offer. So let's take a look into a few why network policies are used in some of the examples where how you would build one and where you would use that. By default, Kubernetes networking model is a flat network, meaning that any pod can communicate to any other pod without network address translation. The pods IPs, they are transient, and the pods themselves, they can move around the cluster and transition from one node to another at the discretion of when Kubernetes control plane decides that the pod needs to be recycled and needs to be moved. So the non-routable IPs, they are not really visible to the firewalls, to the traditional firewalls, and that rely typically on IP address as the identity of the service they are enforcing, or they are trying to provide rules for. With pods, that is not really possible. So with network policies, the specification for network policies was created to allow solve the use cases when the network needs to be segmented. Some workloads need to be protected. So the concept of network policy came to be that instead of using specific IPs on the pods, you would use Kubernetes resource labels to target those pods, to target the workloads. The policy itself, can be written in a YAML format and stored in a standard text file. And the policies are applied through regular kubectl command. What that allows you to do is now you can deploy your policies alongside your application in a typical application lifecycle, where the policy would be checked in with the app and go through your CI/CD process and being deployed to the Kubernetes platform. And you can have different tiers of policies, how you would manage those. Some of them may be managed by higher level teams, the security team, platform team, and the application specific policy can be bundled or tied together with the application itself, so that whenever a new app gets deployed, if there is a change in the policy can be deployed automatically with that app. Just a quick example of a transition from a monolithic type of application to microservices. In a monolith, you would typically have the life cycle of the app is more or less static. In microservices, that's quite dynamic, ephemeral lifecycle for those services. Now, instead of having centralized team and centralized ownership of the app, in the monolithic case, now you have everything distributed between multiple different teams. The communication boundary between the components transitions from in-process in monolith to network, being network boundary. So now your policy enforcement becomes for each individual component. You need to create that policy that would allow only the flows, the communication paths that the application should use to minimize the attack vector. So looking into the example of just standard Kubernetes policy, right here you would see there are 3 top-level fields that show up in most of the Kubernetes resources, like API version, kind, and metadata. By API version, you can tell that this is a Kubernetes network policy, the prefix networking.k8s.io. That represents a standard specification of Kubernetes network policy. And the spec section, that's where the structure of defining the rules for that network policy with the top-level selector. In this case, it's a pod selector, which matches the role DB label. So a group of pods right here in the blue that has that label would be affected by this policy. And this policy specifies ingress section, which means we are configuring the ingress rules for that group of pods, where we're saying that the access from pods with label role frontend, this is this green group of pods, over the port 6379 is allowed. So once you defined at least one rule, deploy policy with at least one rule, now you would explicitly allow that path, and Kubernetes would flip a switch to deny everything else, meaning that if I have some other pod with, for instance, with label role helper, that pod would immediately lose communication to this group of pods, because there is no path in this policy defined for it. So unless you will define another policy or add another group of rules to this policy, all other pods would not be able to talk to this role DB. So let's take a look into the Calico policy model for this and how it differs a little bit. So if you decide to use Calico policies, you would see right away API version here, projectcalico.org. You would see there are some additional fields. The order field allows you to sort the policies and stack them in specific order. So now you can control which policy would take a precedence over other policies. You have ability to select action. Calico policies support 4 types of actions: allow, deny, log, and there is a 4th pass, which mostly used in Calico Enterprise, and I'll show a little bit later where exactly that comes into play. And you have ability to select for more resources, or you get controls to create fine-grained access to in your policy rules. For instance, Calico policy allows you to select for service accounts, where you can say that in our example right here, we explicitly denying the access to pods with a role DB, this blue group of pods. We explicitly denying access to any workloads that are running under service account, SRE account, and have either of these labels, role helper or stage dev. So now not only we can deny by the pod label and the ports, or allow the traffic, we can also do that using such constructs as service accounts in addition to that. Here's another example of using the log action, where we're saying that any ICMP packets from the group of pods with color green namespace, here's representation of those with a role front-end pods running in the color green namespace. We would capture and log all those ICMP packets. And coming to a third example in terms of the application layer rules, once you configure the integration with Istio Envoy, you get access to this to the application layer rules, where you can specify HTTP methods that would be either allowed or denied to be used. In this example, the rule explicitly denies the color red, any pod in color red namespace running under this service accounts that have labels. So we don't necessarily need to specify the name of service account. We can just use either or even both. So we can, in this example, we're saying any service account that has either of these labels and tries to do the post to, here's the path, to this path, that flow will be denied. So let's quickly take a look into the cloud native approach to security versus traditional. Some things that come into play in here that in Kubernetes workloads are ephemeral, they're moving around, IPs are not stable. So the traditional firewalls, they do not, you cannot really rely on the pod IPs to control the traffic. The enforcement of policies needs to happen as close as possible to the workloads themselves. That's what network policies provide you with. For traditional firewalls, that's typically a separate appliance where you need to configure the rules. So you cannot really chase those pods around. That's not really an option. The policy rules in network policy approach in Kubernetes dynamically calculated based on labels. That's the point of stickiness, what typically traditional firewalls rely on the IPs as that point of stickiness. For Kubernetes, that's labels. The application of policies in traditional firewalls the process itself can be quite convoluted or can take days or even weeks. With the approach, or with cloud native approach, where the policy can be deployed alongside the application itself, depending on the process that you set up for your application lifecycle, that can be enforced almost instantaneously. And the integration with service mesh and the knowledge of Kubernetes context for network policies allows them to be applied as close to the workloads and based on labels and namespaces and scoped to the namespaces, versus traditional firewalls, they do not really have that context. So a few features of Calico Enterprise where you get additional capabilities. So with Calico Enterprise, you get some access controls that allow you to fine-grain the access to resources either within your cluster or even outside of your cluster, where, for example, you can allow or restrict specific pods to get access to some third-party APIs like Salesforce, Twilio, or using the DNS egress rule to allow access to your RDS database hosted somewhere in the cloud or somewhere in a different environment. The flow visualizer, that's a tool that Calico Enterprise offers, provides which renders all the communication paths within your cluster. Each line in there represents a specific flow, and the controls, with the controls on the right-hand side, you can filter that out to zoom into a specific namespace or specific workload and see what is happening in that flow. You would get a rich Kubernetes context with each flow showing you from where it was going to the destination and which labels were used in each of those endpoints and what policies were evaluated along the way. The Calico Enterprise provides the ability to preview policies and stage them, which enables you to have this policy lifecycle where you create the policy, then you can preview it and stage before you enforce it. In staged mode, the policy runs in a permissive mode. So you can run it for some time to make sure that everything is fine. It does not really block any flows from any other application where it should have access to. And then you can enforce it. And after that, you just go into regular update, delete it, and close the loop in there. Calico Enterprise provides you ability to create policy tiers. So with a policy tier, now you have a capability of setting up a designated layer for let's say a specific team. You can create tiers and map them out to your organizational structure, where security team or platform team developers would have access to their tiers only, or some of them can have access to multiple, and allow them to configure the rules within their tiers, and therefore setting up the guardrails for any users in next tiers. So in this case, the security team can set up guardrails for some rules that would provide guardrails for the platform team, and platform team can do that for the app team. In terms of using Calico in Openshift, since Openshift 4.2, we've added certified operator, Calico certified operator, to install Calico on Openshift. It is supported with Openshift 3x as well. The installation process was a little bit different in there. It was a little bit more manual with addition of Calico operator to this process. Now it becomes very straightforward. That's you just run create Openshift install, create install config. Replace standard Openshift SDN with Calico, and now you can deploy, create your cluster. We provide integration with Openshift's auth login, and fully supported RBAC and auditing. So the login page, your login page, is backed by login API that Openshift provides. You can use either API server or Openshift CLI to manage Calico resources. So your standard kubectl will work, or if you're using OC command line, that will work as well. It's worth mentioning that the solution, the Calico operator, was fully certified, was developed actually in collaboration with Red Hat's team, and fully certified on Openshift. Okay, I'm going to jump into demo and show a few use cases. So here's my cluster, which runs, I believe it's Openshift. Yeah, it's Openshift 4.5 version in my cluster, and here is the namespaces in my cluster. So you can see most of this just default Openshift stuff, and some of the Calico. I have Calico Enterprise installed in this cluster, which you can see by the Tiger hyphen namespaces. That's where the enterprise components are residing in. So for this demo, I have an application that I'm going to deploy, which is comprised of an Nginx stack. There is a CentOS pod and Netshoot pod that I'm deploying in there. So let's take a look into pods in there. So I got all 4 pods running. What I would like to test is to show you that right now I have full connectivity. So from CentOS, my CentOS pod, I can call my Nginx service, and from Netshoot pod, I can also call my Nginx service. What I want to do next is to configure the ingress rule for configure the ingress rule and take a look how that would change my communication. So now you can see that once I configure it ingress, CentOS pods can still access my Nginx, but the Netshoot cannot. And one reason for that, let me actually bring this here and show you why this is happening. So if I take a look into my policy, here's the policy I deployed, KDS policy allow ingress. And if you take a look into this policy, we are configuring ingress for Nginx, and we are saying that we only allow access from CentOS pod. So in this case, you can see right away that since Nginx is not mentioned in here in the labels, the only path that is allowed, that's from CentOS pod. So the next thing that I want to do is to deploy egress rule. And for the egress rule, that's this one. So in this egress rule, I'm applying this now to CentOS pod and saying that my CentOS pod resides in an S1 namespace, which has this label, compliance open. And I had to label Openshift's Openshift DNS namespace with the label DNS NS true to include that into my egress rules. Ingress rule. And the reason I had to do that, and let me actually show you. So here's my NS1, which has that label, and here's my OpenShift DNS, which has my DNS NS true label. The reason I had to do this is because once you deploy a policy and you specify a certain path, that's the only path that is allowed in there. If I were to deploy my policy with just the label saying that the egress is allowed to compliance open namespace, meaning that I can talk to workloads within my NS1 namespace, I would not be able to resolve the DNS for my Nginx service, which I'm using to talk to Nginx. I would be able to, I can ping and I can go over the IP address of the pods in that namespace because that access would be allowed by this rule. But if I don't have this rule, I cannot resolve the DNS because I need to be able to get out to the DNS. So let's deploy our egress policy and just make sure that everything's working fine. Okay, so our CentOS pod is still able to talk and our Nginx cannot talk to the Nginx. So the next policy that I want to deploy is the policy allow ingress, which is a Calico policy. So in this policy now, I'm saying Calico allows you to have to combine your labels and rules using logical operators. So in this case, I have a selector in Calico saying that I want to allow ingress for ingress into my Nginx pod from pods with labels app CentOS and app Netshoot. So now I should be able to, once I deploy this, my Netshoot should be able to talk to And deploying this, let me use actually example. How would you would use this in Calico with Calico open source? So with Calico open source, you have to use Calico CDL command line tool to deploy your Calico policies. And the format for this right now would be something like this. I did not export my data store type label, so I'm just using that inline in here for this example. So now you can see both of my pods can communicate with Nginx, but the difference between when I just started, when I deployed this, and right now is that now it's enforced communication by the network policy, and that's the only paths that are allowed are the ones that are defined in the network within the network policy. So before I move forward, I want to show you the interface in Calico Enterprise where you would be able to see all your policies. In the policy board in the UI, here's all the policies I've deployed, and some of these are related to Calico Enterprise components, but this first three, that's the policies I have deployed. And here's the example of a tier. Allow Tigera is the tier that is created when you deploy Calico Enterprise, which lists the components of Calico Enterprise. And any tier that is to the left in this UI, that means it has a precedence. Tiers also have the orders. So if I enable here order on each for each object, you can see the tier order is 100 in here, while default is considered to have infinite numbers, so it's the most right tier always. And for the policies, you can also see that Kubernetes policies get by default, they do not support the notion of ordering. So every Kubernetes policy in Calico gets 1,000, order of 1,000, and any Calico policy would get whatever you would set in there. And just enabling additional controls, you're able to see how traffic is moving through those policies in here. So let's deploy additional tier in here, a security tier, and take a look. Okay, now I got my security tier deployed, so I can start deploying policies into that tier. So a few examples I want to set up and show you how alerts work in Calico. So I'm going to deploy a few alerts, and then going to deploy a few next scenario for to show you how you can leverage DNS policy in Calico. So here's my other screen, and I've set it up so that it's easier to look through, to look into the components that are running and the curl commands that I run within each pod. Let's take a look into this namespace. Make sure that all our components are deployed. So I got similar setup. I have in namespace 3, I deployed CentOS, Netshoot, and Nginx controls. My CentOS, if I tail the logs of my CentOS, I'm curling the Google DNS from CentOS pod, and from Netshoot, I'm going and curling the Nginx service of the Nginx deployment. So what I'm going to do in this namespace, I'm going to deploy let me show you. I'm going to deploy the explicit deny all policy. So here's the policy that would deny all the traffic within my namespace, so that then I can start whitelisting and only allowing the traffic that I want to flow within that namespace. This is also one of the steps or approaches taken when you take zero trust networking approach to securing your network. So you would deny, since Kubernetes by default allows communication for each pod to talk to any other pod, we can use network policy to explicitly set deny all the traffic and then start whitelisting the traffic. So in my case, let's see, I'm going to deploy this policy, and you should see this. Yes, the curl commands stop in both of my pods. So now I have a few sets, a few network sets that I want to deploy, and the network sets are components I can quickly shown here. These are resources of Calico Enterprise, where you can define lists of network ranges in CIDR annotations or domains, and you would then you can target them within your policies. So that allows you to maintain this list and not being tied to a specific policy. You can change this list at any time, and your policy would still enforce that change. So now, since I deployed the egress, or not egress, the default deny, I want to make sure that my pods will be able to talk to the DNS. So this policy is what I'm deploying next, saying that it applies to my CentOS pod, and I'm allowing the communication over ports 53 and 5353. The latter used by Openshift, the former is used by most of other Kubernetes distributions. And in here, here's an example of DNS rules. I specify that I allow this pod to talk to google.com and start.google.com. But then my last rule says I'm denying access to any other destination that is specified by a resource with this label, type and S3 public. So, and this is one of my network sets in here. So in S3 public, here's the label. So I'm saying that this pod would not be able to communicate with all these networks, which pretty much most of the public networks. So let's do this. So now you can see my CentOS pod, which is a top right, started communicating, started being able to curl my Google domain. And just to close the loop, let's deploy a few more policies to allow Nginx to talk to allow Netshoot to talk to Nginx again. So, and that's ingress and egress policies for Nginx. So now Nginx is able to talk to that. And just to show you that I can talk to Google domain, but cannot talk to others. You can see if I curl Google, I do get a response from CentOS. But if I do that for let's say Apple domain in here, I'm getting my timeout. That's because I specified just the Google access that is allowed. And just to show you a few, maybe run a few more times this to see if we can catch the briefly catch this in our alerts. So while And while we're looking at that, here is the live view of Flow Visualizer in Calico Enterprise, where you would get all these flows. And so I can drill down into my namespaces and start zooming in and looking at the traffic. So on the right-hand side, you can see the context related to this flow, where you see ingress policy and egress policy that gets applied. You see the source and destination labels for each of the flows. And so you can just go through each flow and kind of take a look and see what's the source and destination, what that flow represents. So in this case, for instance, here's the CentOS talking to DNS. And we have egress policy that allows that communication. And if I jump to the compliance reports, that's another tool which allows you to see what is your level of compliance, how many ingress or egress endpoints are protected within your cluster. So in my cluster, you can see I deployed only a few policies, so there isn't that big of a coverage right here. But you can configure these reports and kind of start looking at them to see. Here's another example for a policy audit, where you are able to see within the scheduled period as report runs, how many policies were created or deleted, or any policies that were modified. And if we come to the alerts, looks like I didn't configure the alerts fully. Let me check if I missed a step in here. Yeah, I did not configure the alerts. Looks like I missed a step somewhere. But once, let's see, did I deploy any alerts? Okay, so here's an alert that I deployed, which looks for any change in the global network set resource. Here's the query that defines that. So if I go and start modifying some of my network sets, like let's say P range, and let's say I'll remove one of this, and let the collection of flow logs and the audit log to happen. And I should be able to see in a moment the alert showing up. All the changes that are made to the policies will be represented in a timeline, which is available here in the timeline board, as well as on each of the policies. If I were to change, let's clean this up a little bit. If I were to change, for instance, this policy, the change would appear right here. So one of the examples that you can make in here, let's say that I'm not going to allow this flow, but rather I'm going to deny. And go ahead and take a look. Go ahead and preview this policy before I go further with the policy. So now you can see, if I zoom in here, so now you can see what would happen. It's showing me right away that the flows would start getting denied. And on the right-hand side, you can see the representation of what would happen if I were to go and deploy this policy. So I'm not going to do this change. And let's take a look if we got our alert. Yes. So here's the example of an alert. And if you remember, I made several requests to Apple domain. and one of my alerts captured that, and the alert was set to watch for any access to the domain that I wanted to make sure that no one can access. So for example, the alert itself, here's the configuration where I'm saying look for any request to apple.com or 3w.apple.com and alert on any amount of those queries. Okay, so jumping back to my slides. So to sum it up, the Calico network policies or the Kubernetes network policies with in the cloud native approach to developing new applications is a mechanism, is a tool which you can use to segment your controls within Kubernetes, your Kubernetes environment, and protect your workloads. Calico network policies are a superset of Kubernetes network policies with some advanced features that allow you to solve real-world use cases. Calico is offered in many of the Kubernetes distributions, in managed cloud distributions, as well as packaged solutions, widely adopted by the community and recognized in the community. Calico enables comprehensive network security in Openshift for workload hosts and control plane, and fully certified with the Openshift, and it's been proven in the large scale in production deployments. If you are interested in trying Calico Enterprise, then you can head to this URL, tigera.io/trial. We will set up the Calico environment for you that will be automatically provisioned. And if you are new to it, you can follow the guided labs that are provided in that environment. Or if you feel comfortable and just want to test out specific use cases, you can do that as well. Here are a few upcoming events that we are doing. So we typically do 2 events per week, sometimes fewer than that, but running this on a regular basis, some of them in EU time zone. So if you have your friends in the EU and you would like them to join, make sure you'll tell them about that, or just direct them to tigera.io/events. You'll see the next sessions. Thanks, and let's take a look at any questions you might have. I do not see any questions as of now. I'll keep this session open for another minute or so. If you have any questions, please feel free to type them into a Q&A session, Q&A window, or just simply in the chat. That's fine too. I'm monitoring both of those right now. If you don't have any questions, I have probably 3 minutes left. I can show you one more thing in here. So one other tool that Calico Enterprise provides, that the access to the flow logs, leverage Kibana to visualize, to view the raw flow logs collected for your cluster. So if you go to your Kibana dashboards in cluster set up with Calico Enterprise, you would start seeing all of this flow logs collected in here. So if I start drilling down into any specific one, you would see all the information that is collected. You can see that the entire Kubernetes context that I previously mentioned a few times is collected in this flow logs. You get the traditional IPs, which you can still use, but they're not as relevant as, for example, the labels on the pods. You can also see the node where this came from, the host where this pod was running at the time when a flow log was collected, and all the information about the policies evaluated on this flow and the decision made also captured in here. So you can see the IPs, ports, all the labels, and policies captured in here. Okay, last one check on the chat and Q&A. I don't see any questions. Thank you for attending this session. Hope to see you in other events that we are running. Thanks, bye.